Hello, I'm Pushkar, Master Teacher in Chemistry at Vedantu, and I'm discussing JEE Advanced 2020 Chemistry Paper 2 problems. So let us see this problem. This is question number 17, numeric type, which has been asked in Paper 2. So if you go through this problem, tin is getting reduced by coke and some data is given. And it has been asked at what temperature the reduction of cassiterite by coke would take place. So the theory of problem is, let me discuss the theory of this problem. In this problem, you have to calculate the value of delta RH naught of the reaction, enthalpy change of the reaction. You have to also calculate delta RS naught of the reaction. And then we know that delta G naught is equals to delta RH naught minus T times delta RS naught. Also, we'll have to see that what are the signs of delta H and delta S. In this particular case, upon solving, you will be finding that this is positive and this is also positive. So which means that if you increase the temperature, this term will become more and more negative, and at sufficiently high temperature, delta G naught will be negative. So that means the reaction will be spontaneous above temperature at which delta G naught is equals to 0. Delta R G naught is equals to 0. To find this condition, we have to set delta R G naught is equals to 0, and which gives you the temperature is equals to delta RH naught upon delta RS naught. So by doing this, you will get the temperature, and above this temperature, the reaction is going to be spontaneous, because above this temperature, delta G R naught of this reaction, that means reactions delta G naught, is going to be negative. In this question, we'll have to assume that delta RH naught and delta RS naught are not varying with temperature. In fact, these quantities also vary with temperature, but it was clearly given in this problem. Assume that the enthalpies and entropies are temperature independent. That means they are not changing with temperature. That's a very unreasonable assumption, but we have to take it for solving the problem. So with keeping in mind all these things, you also have to take into account from the given data, delta RH naught reactions enthalpy change is equals to enthalpy of formation of products minus enthalpy of formation of reactants. So that is the standard formula that we have to use, and you have to use this also. Delta RS naught is equals to entropies, standard entropies of products which are given, minus standard entropies of reactants. So doing this, you will be calculating delta RS naught. Doing this, you will be calculating delta RH naught. And by substituting these values, you are going to get delta RS naught. The temperature at which this reaction is going to be at equilibrium, and above that temperature, the reaction is going to be spontaneous. So let us see what are the values given. See, delta HF naught of SnO2 is given, delta HF naught of CO2 is given, and the given reaction will be cassiterite. The formula is SnO2. This is reacting with carbon, and it is going to form tin plus CO2. So this is the balanced equation for which you have to find the delta RH naught and delta RS naught. Now, as you can see, the enthalpy of formation of this, delta HF naught of this will be 0. Delta HF naught of this will also be 0. It is not given in the data. You can see it, check it out. Okay, why? Because they are elements, and elements in their most stable state will have delta RH naught equals to 0. Delta HF naught is equals to 0. Also, it is not mentioned here that coke is in graphite form, but you will have to take that this carbon is in graphite form, because only for the graphite, which is most stable state of the carbon, we take delta HF naught is equals to 0. So these things has to be kept in mind while solving the problem. So I would say that when a student go through this problem, he will face these problems. Okay, he'll have to overcome these thoughts. They will definitely come. But eventually, if you are not using this value, you could not find the delta RH, delta H naught of this reaction. So automatically you will have to make this assumption that the carbon here is carbon graphite. So by substituting these values now, I've already written on the formula, you're going to get this value of delta RH naught, which is 187 kilojoules per mole, and delta S naught you will get by substituting the values of S naught. You will get it is 200 joules per Kelvin per mole. From this, you will calculate the temperature, which is delta H naught upon delta S naught. That will come out to be 935 Kelvin, and above 935, if T is greater than 935, this reaction is going to be spontaneous. So your answer is 935. So I hope that you understand all the assumptions taken to solve this problem and how to solve the problem. What is the funda or the basic thought behind this problem? These types of problems are quite common nowadays in JEE Advanced, and at least 1 or 2 questions from thermodynamics you will always see in the advanced paper. Thanks for watching. For more detailed solutions of other questions, stay tuned. Thank you.